Alright, hey everybody, so someone's I think I accidentally kicked someone out. Uh, Oops, unlucky. So let's just start. We're gonna be going over USACO US Open, the past one on the 2nd to 5th of April. And we'll also go over some other little stuff, and then at the very end we'll go over that Python rock paper scissors competition we started last time. But first, a quick one general announcement is officer applications. If you're interested, you just go to this form. There's no like prerequisites. I mean, there are some obviously, but like there's no big ones other than you can't be a senior because it just doesn't work like that. And everything else we'll just judge ourselves. We probably won't like make decisions until maybe later on, like maybe next school year start, whatever. So if you're interested, you can fill it out, or you could always fill it out later. I didn't put a deadline or anything on it because it's nothing really like too late. But if like you fill it out like way too late, we might not contact you because it's too late. So if you're interested, you can go to this later after the slides are posted. But for now, let's just go to the USACO. So Acowdemia I, this is the first problem. It says that Bessie DeCow has enrolled in a computer science PhD program, driven by her love of computer science and also the allure of one day becoming Dr. Bessie. Having worked for some time on her academic research, she has now published N papers. N goes to 10 to the 5. Uh, and her I paper has accumulated C to the I citations and is also 10 to the 5 from other papers in the research literature. Bessie has heard that an academic success can be measured by their H index. The H index is the largest number H such that the researcher has at least H papers, each with at least H citations. Yikes, I can't speak. For example, a researcher of 4 papers and respective citation counts 1, 100, 2, and 3 has an H index of 2, right? Because they have 2 papers with indexes of 2 and greater. It can't be 3 because it doesn't have 3 papers of of index like of. It doesn't have 3 papers of at least a score of 3. It only has 2 with at least a score of 3. But if the citation counts are 1, 100, 3, and 3, the H index will be 3, right? Because they have 3 papers with a score of at least 3. This one only has 2 papers with a score of at least 2. And to up her H index, Bessie is planning to write a survey article citing several of her past papers. Due to page limits, she can include at most L citations in this survey. L goes to 10 to 5. And of course, she can cite each of her papers at most once. And then help Bessie determine the maximum H index she may achieve after writing the survey. And then this is just whatever. It just says, note that Bessie's research advisor should probably inform her at some point that writing a survey solely to increase one's H index is ethically dubious. Other academics are not recommended to follow Bessie's example here. So first line contains N and L, right? N is the number of papers she has, and L is the number of citations she can cite in that one survey. And after that, it contains her for her N papers, right? In this case, it's 4, and their number of citations, or C1, C2, C3, whatever. And so in this case, she has 4 papers, 1, 100, 2, and 3. So her H index is 2. And then she's allowed to cite 0 papers. So obviously you can't increase her H index. So the output is just 2. Next one, 4, 1, 100, 2, 3. So it starts at 2. She can cite 1 paper. If she cites her third paper, which is this one here, then the citation becomes 1, 100, 3, 3. And so the H index becomes 3 because now she has 3 papers that are at least 3. And that's basically it for the problem statement. So this is the code. I think there's a better way to find the H index with like binary search, but this way works too. So I'm gonna run through my code. We have 3 integers that are declared, N and L. Those are the inputs. HIND, it stands for H index. And then we have an array which stores Bessie's N papers. Then input function, so taking the input, we store an N and L, we create a new array of length N, and we grab all 4 or all N of her papers and store them into the array. And then to calculate, yeah, I'll reshare my screen. Oh, thank you. You guys can see my VS Code now. Oh, oops, my bad. I'll restart. So Thanks for letting me know. So there's declared three integers, n, l, and hind. Right, hind is h index. We declared an integer array which stores her n papers. Input function, we take the input, we take in n and l. We create a new initialized array of length n, and we take in all n of her papers. Then we sort the papers. So the way I found the h index was I sorted the array from decreasing to increasing, and then we use a two pointer to go forward and calculate the h index. So for example, if we have like the scenario where it's 1, 100, 2, 3, I'm pretty sure that's what it was, right? And so after we sort this, it becomes 1, 2, 3, 100. And then the for loop, the way it works is we initialize I equals 0 and j equals n. So um, I is equal to 0, j is equal to n, which is 4, right, in this scenario. And as long as I is less than n, which is, so as long as I goes from 0 to 4, right, so 0, 1, 2, 3. Then we increment I and decrement j. So I goes to 0, 1, 2, 3, and we increment I and decrement j. And each time we check if that paper is greater than or equal to j. And if it's less than, and once it is, then that's where the h index is. So the way you can think about it is if we start at 0, we check is array of 0, right? So is 1 greater than or equal to j, which is 4. 1 isn't greater than 4. So we move on to the next one. Then is 2 greater than 3, right? Because we incremented I, decremented j. So is 2 greater than 3? 2 isn't greater than 3, so we move on. And then we check is 3 greater than 2, right? Because this one is 3, and we decremented j, which is now 2, and 3 is greater than or equal to 2. So then our h index is just j, which is 2, and we break. And this works for all of them, right? So if, for example, our array was 133, 100, then it would still work, right? One is not greater than one is less than 4. The next one, which is 3, is greater than or equal to 3, and so the h index is whatever j is, which is 3. And so that's how I calculate the h index. And so after we grab this, we store the initial h index, and then we run a function called solve. And solve first checks for two edge cases. So if the h index is equal to n, you can't increment the h index because you're already maxed out, right? Because if n is 4 and your h index is 4, no matter how many more times you cite the papers, you can't get to 5 because to get a 5, you need to have 5 papers that are at least score of 5, and you won't ever reach 5 papers if n is equal to 4. So if hind is equal to n, it doesn't work. And then if L is equal to 0, right, that scenario where we are only allowed to cite 0 papers, then there's no point. So we just print out the h index, which is our answer, and then system.exit 0, exit with a success status of 0, and that's it. And then the other scenario is if L is greater than n minus h index. N minus h index is the number of papers that Bessie has that isn't contributing to her h index. So in this scenario here where it's 1, 2, 3, 100, right? She has 2 papers that aren't contributing to her h index. She has 1 and 2, right? Because her h index is only 2 and it consists of 3 and 100 basically. 1 and 2 aren't helping. So you want to like increment 1 and 2 if you have extra citations, right? So if L is greater than n minus h index, that means that we have more citations than the papers we don't have. So if L was 3 and we have this scenario here, we can increment 1 and 2 and we can increment another paper. So we can increment 3 also, right? So then we would increment 1, 2, and 3 to 2, 3, and 4. If we don't have enough, so let's say we only had 1 and n minus h index was 2 in this scenario, right? So we have 1, 2, and you only had 1 L, then you can only cite 1 paper, and we want to cite this paper here, number 2, right, to increment it. But if we have more than enough, then we just start from 0 and increment each one plus plus, right, by 1. And then we do math.min of n and L because if L is greater than n, we don't want to go past it. We'll get an array out of bounds exception. And the other scenario is if L is less than or equal to n minus h index, then this time, right, we want to start from right here. We want to start right here and go backwards to the left because these are the most important papers that will help Bessie. And so we start at n minus h index minus 1. As long as it's greater than n minus h index minus 1 minus L, then we I minus minus, and we increment that one. There's definitely a better way to do it, but this way works also. The time allows. And after that, we recalculate. It's the same as Actine. We sort it and then use the 2-pointer and find the h index, and then we print it out. And that's problem 1. And it works. It's all 17, and the time could be improved, but it's not bad. And the second question, I'm gonna quickly read it. It took a lot of time on the first one. The second question, so Bessie is applying to computer science graduate school and has secured an interview at a prestigious computer science lab. However, to avoid offending anyone, she's interested in determining the relative seniority of the n current members, which is only 100. No two members have the same, but determining their seniorities may be tricky. So to do so, Bessie will look at lab publications. Each publication contains an author list, which is an ordering of all n lab members. It's in decreasing order of the effort each lab member contributed to the paper. And if multiple researchers put in equivalent effort, then they're ordered by alphabet. And since more senior lab members have additional administrative duties, a more senior researcher never puts in more effort than a more junior researcher. This sentence is super confusing. What it means is that the more senior the person is, the less work they put in. And that's what you need to know. And then, so for example, in a lab consisting of Elsie, Mildred, and Dean, there may be a paper which is Elsie, Mildred, Dean, if all of them put in different amounts of effort, right? And then so Elsie puts in more effort than Mildred, who puts in more effort than Dean. However, there may also be a paper in the order of Elsie, Dean, and Mildred. If Mildred and Dean put in the same amount of effort, then Dean will be listed in front because it's alphabetical. And so given the K publications, which are up to 100, help Bessie determine all pairs of researchers who is more senior if it's possible to tell. Sample input gives you K and N, and then the first line gives you the 3 people, and then the next K lines gives you N space separate strings indicating the author list for one publication. The output's also tricky. It's an N by N array, and then I'll read it. The output should consist of n lines, n characters per line, n by n. On line I, so on line 1, if j is not equal I, character j should be 1 if the ith member is definitely more senior than the jth member. 0 if the ith member is definitely more junior than the jth member, and question if it's impossible to tell. So what that means is, and then character I on line I should be B because that's Bessie's favorite letter. So what that means is on line 1, character 1 is always B, 2 is B, 3 is always going to be B. Same as here. And then in this scenario, right, Dean, which is the first person, Dean is more senior than the second person, Elsie, because of the ordering. So you put a 1 here and a 0 here. Dean is also definitely more senior than the third person, which is Mildred. So we put a 1 here and a 0 here. And then for Elsie was more junior to Dean, so that's a 0. And Elsie is a question mark to Mildred, right? And then same thing with Mildred, more junior than Dean, so that's a 0, and then it's a question mark to Elsie. Yeah, that's how it works. And the reason why it's ordered like this is because Elsie, Mildred, Dean, everything is in alphabetical ordering, right? Except for Mildred and Dean. So what that tells us is Elsie and Mildred. Basically, what it tells us is that Dean is for sure more senior than Elsie and Mildred because this is not an alphabetical order right here, right? For Elsie and Mildred, we can't tell because maybe Elsie and Mildred put in the same amount of work and so it's just alphabetical. But for Mildred and Dean, because it's not alphabetical, we know for a fact Dean is more senior than Mildred. And then by like chain, right, Dean is also more senior than Elsie. And that's like the trick. So basically, let's look at the code. Basically, if at any point one string, if it's all alphabetical, you can't tell anything because all of them might have put in the same amount of work. However, at the first point where it becomes non-alphabetical, then that means the people to the right of that split have put in more work than the people to the left of that split. So what I mean is, right, how you want to do this is you want to just iterate from left to right over your author list and check if it's alphabetical. So right now it's alphabetical. Mildred and Dean is not alphabetical. So this is where you split. and everything to the right of the split, Dean and everybody else, is going to be more senior than everybody to the left of the split. If you imagine this with Elsie, Mildred, Dean, and let's say Bob, just for example, Bob is right here, then Elsie and Mildred are still question marks. Mildred and Dean is more senior than Mildred, and then Dean is also more senior than Elsie. Then Bob is also more senior than Mildred and also more senior than Elsie. Bob is actually more senior than Dean, but we don't need to worry about that. And so that's the trick. This question is very confusing because like the wording of the problem statement is super confusing and the solution is kind of confusing. So the way did it is store k and n, which are the numbers they gave us. We have a hash map, and it stores the order of the lab members. The key is string, the value is integer, and the output format, which is a 2D array, a 2D character array. We take in the input, so we take in k and n. We grab the first line, which is the lab members in their order. So we take it as a string and we split it by the spaces. And in each one, we put it into the map. So we put the string and then the order, right? I is their order from 0 to n minus 1 because we want it to be ordered because the answer needs to be in that order. Then we initialize the answer to a new character array, it's n by n. And then we fill all of them with question marks. And then each time it's an I, it needs to be B, right? So we just do that. And then we loop through the k publications. And each time we run function solve, which takes in the string, which is the author list. Solve taking in the string, which is the author list. We first split it, to give us split it by space. So all we're left with is the names in an array. We loop through the array. We have a Boolean, which is ABC. If it's alphabetical, it's always set to true. And then inside the array, we start at the next point on and check continuously if it's true or false. And the way we check is we take the one before array of j minus 1, which is a string here, right? So if the previous author name compared to the author name we're on right now, if it's greater than 0, ABC is false. What this does compared to is compares two strings, right, by alphabetical. And if it isn't alphabetical, right, so if this one is greater than 0, basically this just, all you need to know is this just compares two different strings. And if this first one is greater in alphabetical than this second one, then ABC becomes false, right? So this just triggers if everything is alphabetical. If this if statement is true, then that means this is not alphabetical, and we set ABC to false. And if ABC is false, then we add them into the hash map, 0 and 1, junior and senior. And that's all we need to do, and that's the whole solution. It is pretty tricky, but I recommend if you still don't understand it, play around with it and like debug the statements and see how it works. But it does make sense, and it just uses that format of at each point you check once the thing becomes not alphabetical, then everything to the right is more senior than everything to the left, and you just loop over and check every single pair. That's why we have a nested for loop. And then the last one, the last problem is Bessie is a busy computer science graduate student. However, even graduate students need friends. As a result, Farmer John has opened a pasture with the explicit purpose of helping Bessie and other cows form lasting friendships. It's a 2D grid of square cells, so it's a 2D array. Each cell is either a C or G or a dot. A C is a cow, a G is a grass, a dot is neither. And then for two distinct cows to become friends, the cows must choose to meet at a grass-covered square that is directly horizontally or vertically adjacent to both of them. So what that means is it has to be to the left, to the right, to the top, to the bottom of both cows. I'll explain later if it's confusing. During the process, they eat the grass in that grass-covered square, so future pairs of cows cannot use that square anymore. And then no pair of cows can become friends more than once. And then Farmer John is hoping that numerous pairs of cows will meet and become friends over time, determine the maximum number of new friendships between distinct pairs of cows that can possibly be created by the end of this experience. First line contains N and M. The next is N lines, each having M strings of character describing the pasture. And then you output the maximum pairs of cows. So in our case here, the sample output is 4 because the cows at 2, 2, and 3, 3 eat the grass at 3, 2. So 2, 2 is 1, 2, 1, 2. So this cow right here, 3, 3 is right here. these cows eat the grass at this point right here. So this cow and this cow become friends because they meet at this grass cell that are vertically or horizontally adjacent to both of them, and they eat the grass here and they're friends now. Cows at 2-2 and 2-4, so 2-2 and 2-4, they eat the grass right in the middle of them, which is 2-3, and they become friends now. This grass is gone. The cow at 2-4 and the cow at 2-4 and the cow at 3-3 eat the grass at 3-4 right here, and they become friends now. The cows at 2-4, where's 2-4? 2-4 is here. The cows at 2-4 and 1-5 eat the grass at 2-5, and they become friends now. So hopefully that makes sense. And the trick is you have to realize two things. One, loop through every single grass cell and see if you can combine cows at that grass cell. And the second thing is you want to combine cows that are either both on your horizontal sides or both on your vertical sides first. Because the issue is, so the first thing you want to do, right, is you want to loop through all grass cells. So you would do a for loop over all of this big array, and then at each point you would check if is this point a grass cell, right? And if it is a grass cell, then you want to check, does this grass cell have two cows vertically or horizontally adjacent to it? And if it does, you want to start pairing them, right? And you can only pair one set or one pair of cows. So you want to be able to choose which cow to pair. The reason why you need to choose is because, for example, let's say this grass right here in the middle of 2-2 and 2-4, let's say the cow at 3-3 and the cow at 2-4 met here and ate this, right? They met here. This grass would be covered, and now the cows at 2-2 and 2-4 can't be friends because the only grass cell that they have that's common right here just got taken over. But these two cows here, right, 2-4 and 3-3, they could have met here at 3-4 and become friends anyways, and allowed 2-2 and 2-4 to become friends. But instead, they went this way and took the only grass cell that 2-2 and 2-4 can become friends with. So that's why you want to first make friends with the cows that are left, right, or top, bottom. And then you want to add, if those scenarios aren't there, then you want to add the cows that are top right, top left, or bottom right. And that's it. So we initialize N and M, and then we have a char array, 2D array, that's the board. We take in the input, we take in N and M, we create the new char array, and then each line we convert it to a char array. Pretty simple. And then solve function. So we loop through every point and check if it's grass. Then we check immediate adjacent cows. If there are two on opposite sides, then they are first priority for friends. Opposite cows can only be friends at that grass cell, but the other 90-degree cows, right, the other 4 90-degree cows can be friends at another grass cell. And then we take the 2D points into 1D compression, and we do that one more time before inserting it into the set. So this part's the really confusing part. So we create a set. A set is basically, you can think about it as like a storage. It's a date. You can think of it like. You can think of it. What's unique about a set is it does not contain unique values. So if I initialize a set and it stores integers, and I add 1, and I try adding 1 again, it won't take the other 1. It's only going to have 1, 1. It does not take duplicates, basically. That's the benefit of a set. So I can add in 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5 again, and it's only going to have 1, 2, 3, 4, 5 at the end. But if I have like an array list and I add 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5 again, it's going to have 2 sets of 1, 2, 3, 4, 5, right? But a set is only going to keep the first, it's not going to have duplicates, right? So we store everything into sets. And then 2D array into 1D compression. If you look at this example here, right? So let's say we have a 3x3 array. The way you would label this is you would label this as, this is 1, 2, 3, and then this is 1, 2, 3, right? That makes sense, right? So, and then this is like dot, grass, cow, whatever, just, you get the point, right? So, and you have a 3x3, right? And so you call this point here 1, 1, right? But the issue with that is you're calling 2 numbers. And so a better way to do it is actually if we compress into a 1D array, and this point right here, instead of being called 1, 1, is going to be 1. This is 2, this is 3, And then this one below is 4, 5, 6, and this one's 7, 8, 9. So 9 is equal to 3, 3, 8 is equal to 3, 2, 7 is equal to 3, 1, and so on. The way you do that is, the formula is you take the I, right? Or you take the I, you multiply it by M, and you add J. I is equal to the X, and the J is equal to the Y. Yeah, I is equal to X, J is equal to the Y, and M is equal to uh, the length of the array left to right. So in our case, the length is 3, right? If this was 4, the length would be 4. And then so that's how it works, 1, 1. However, we would normally start this as 0, right? 0, 1, 2, and this would be 0, 1, 2. So actually, instead of 1, 2, 3, it would be 0, 1, 2, 3, 4, 5, and it ends at 8. And that's how we're going to count it. Oops, my bad. And so that's how we compress the 1D. And then after we compress the 1D, we're left with two numbers. So let's say we're left with the numbers 0 and 1. Let's say we're left with numbers 0 and 2. There's a cow at this point and a cow at this point, and they become friends here, right? So we're left in 0 and 2, and we want to insert this into our set. However, once again, this still isn't, compressed. This is still two numbers. So to compress this, we do the same idea. We do the first num, which is 0, multiplied by n times m, right? N times m, and we add it to the second num. And then we make sure first num is smaller than second num. And so that's how we guarantee that every pair of cows, every friend is unique in one integer format. And so we loop through the 2D array and we check if it's equal to grass. If it's equal to grass, then we first check above and below, right? So if I is not equal to 0 and I plus 1 is not equal to n, and mat of I minus 1 is equal to c, and I plus 1 is equal to c, then we do the first and second, right? We 2D to 1D. Then we grab the minimum of first and second, multiply by n times m, and add it to the max of first and second, and add that into your set. And then we do the same thing here, but we check left and right first. If 0 and j plus 1 is not equal to m, and if they're both c, then we do the same thing. And then after that, we can check the other 490 degrees in any order, it doesn't matter, and we add it. So in this one is I minus 1 and j minus 1, I minus 1, j plus 1, I plus 1, j plus 1, I plus 1, j minus 1. And we add it to the set, and we print the size of the set, and that's your answer. I think this way works pretty well. The only problem, I think this is actually the fastest way, I want to say, but I'm unsure. If you have any questions about these, you can let me know. The code is already on the GitHub, and that's basically it. Josh, you want to take over?
Yeah. So let's just we're gonna move on to our rock paper scissors competition. So if anyone wrote a bot, they scripted up. If you could somehow send it over, whether that be in like a Google Docs or a Java or Python file, my bad, Python file.
How do you want us to send it over?
You could send it either as a text document or a Python file.
No,
I
like
think I don't
like
know if you could attach it as, oh, you could attach a file directly, I think.
into Zoom?
Yeah.
Okay. I'm a private message you, so nobody
Oh
copies
yeah,
my
private
tea.
message your thing if you don't want other people to see it.
Did he get mine?
Yep.
All right, cool.
Yeah, if anyone has a file, but they're still uploading or getting it, send a message real quick so I know to wait.
Well, I mean, I'm trying, but I don't know how to send a file to Discord.
Oh,
Um,
can
you could do it
you?
you could do it through Zoom. If you go to Zoom and you open chat, you can see there's a on the bottom right of the chat text box, there's a part that says file, and you can attach either a text file or a Python file directly.
If you can't private message Josh, you can message it to me, or you can just put it in the everyone chat, and it should be fine.
Oh yeah,
Also,
that's true.
yeah, I just realized he might not be able to
That's a
private
good point.
message you. Yeah, if that's the case, just private message me, or just put in the everyone chat, and it'll be fine.
Actually, I sent it. Yeah, I sent it.
Yeah, I gotta hang on setting up.
Also, I guess since it's like 109, if you guys need to leave, feel free to do so. Like don't feel pressured to like stay and watch us play rock paper scissors if you need to leave. But otherwise, this is also our last meeting in case you guys didn't know already. So we won't see you guys again this school year, but we will see you guys next school year, hopefully in person at lunch, during Blackford, or worst case maybe we'll be on Zoom again or something. Um, can't say for sure, so we'll let you guys know later as the school year goes by, or as we get closer to the school year. And lastly, remember, if you were interested in the officer applications, they will be on the slides, which will be sending out like after the meeting, within like 30 minutes, an hour. Normally doesn't take that long. Yo, Josh, you still setting it up?
Hang on, I'm almost done.
All right, cool. Take your time.
AI. Okay, so to all who remains, I'm gonna share screen real quick. We're gonna do, I think let's do two separate ones. One of them is short, which is 100. So that's like minimal learning, and then 1,000 to see if maybe you have a better learning algorithm that kind of has like a better curve where it picks up later on or something like that. So we're gonna run 2 times, and we're gonna check the winner for both.
Wait, should we like reveal what our bot strategies are, or like argument at
You,
the end or something?
yeah. Do you want to review right now?
It wouldn't affect the outcome right now, right?
No, it won't. It won't.
I think we're reviewing now. So you want to go first, Josh? I think yours is probably like one of the best.
It's not. It's mush. I don't understand what went on. I gave each bot 2 to see how they will fare against each other as well. So
Oh, okay.
I don't know if you
So what's your strategy?
it just looks at patterns. So if they threw like a set of throws previously, then if like the current pattern matches the previous pattern, it tries to predict the next one. It's kind of wonky. And what about Eric's?
Mine's random. So like
That's
it's
very
just
nice.
it's a lot of different random ones. Yeah, so
And
like it's random on random, you know? Yeah, so it's very random.
I like that a lot.
No problem. I
And
was hoping it would, confuse your butt. We'll see.
I don't know. Okay. So, Chandra, do you want to share or do you just want to run it?
So it just takes the probability. It first looks at what each team put before the previous one, and then it just takes the probability of which one's most likely to come next, and then it just chooses that one, the one against that one.
Okay. Okay. So let's try it now, I guess. 100. This is for 100 rounds. And the winner is Chandra's spot with 506 wins. Let's look at his spot.
Wait, what? Wait, so who's who? How do we tell? Oh, is it by the bot
We
strategy?
can see here. So we don't care about the first few ones. He loses to the my pattern prediction, but he wins against Eric's random.
Oh,
And
unlucky.
then he demolishes the beat last. And the other ones.
Wait, so how many wins out of how many? 1,000?
506 against 1,000 out of 1,000. Funny thing is his bot is so good at predicting his own bot that they tie every single round. I think that's tie, right?
Oh.
Yeah, it's tie. Interesting.
Mhm.
Alright, so your bot ties against itself. Meanwhile, Eric's bot is this one 7 and 9. They're also kind of split 21-20.
How did I do? How many did I
Loses
win out of
against
1,000?
pattern. Well, actually, I can't tell if that's lose or win. I think it's lose win tie. So he loses 2 pattern prediction too. Judging by the general looks, he wins here. I can't tell. This thing is scuffed.
How do I
They
lose the
sometimes
pattern prediction?
they
It's
sometimes flip
random.
they sometimes flip numbers around, so I really can't tell.
Unlucky.
I mean, you win quite a few times, but I can't tell which one wins more. And I don't know. I don't trust these numbers because they flip themselves around.
Do you know how many I won out of 1,000?
You got 304 and 329.
That's not bad. How'd you do?
I got 492 and 478, and Chandra got 48 and 506. Cool. So Chandra wins the 100. Let's try to move to 1,000. Actually, hang on. Before we go to 1,000, let's try taking all the bot teams.
Okay.
So it should be that. And then see if that changes any of the outcome. And after that, the pattern prediction wins, followed by, followed somehow by the random. Wait, no, that's pattern prediction. Random is still last. And Chandra comes next. So he just takes advantage of the bots. Interesting. Very nice. And then for 1000 with the bots back in, it's gonna take a bit of time. Yeah, pattern prediction actually pulls ahead for 1000 and then not very far ahead from Chandra's pasta bot.
What's Pasta 2.0?
It's pasta. I had to rename it differently. It's just pasta. The same as
What's
pasta.
Pasta?
I Chandra's. Do you want to
Chandra,
look at
yours
it?
is named
Chandra,
Pasta?
do you want to show Eric your code thingy?
Well, we just called it pasta because it's just so big and so long.
It's a
Oh,
spaghetti
okay.
code. It's the peak spaghetti code.
Yeah.
I mean, it is
Wow, that's a lot of lines.
339
300
lines. Holy
lines.
smokes!
Oh,
What in the world?
It takes a probability for not only their history but our history as well if they're trying to respond to ours. So we just pick the
Interesting.
highest probability.
Oh God,
that is
that's
nutty.
very nice. Oh, we also have Eric's is a very nice 29 lines,
Yeah.
and mine is 54 lines. Oh, yeah. Okay. So Chandra, you win. You win the 100 with bots. So congratulations. So you're the default winner because you're also the only one other than staff to play.
I mean, I just used the code that I had from last year.
I know. This is literally okay. Bye bye.
Alright, see you guys.
Thanks, Steve.